Introduction. Standard specified for secure hash algorithms SHA-1, 256, 384, and 512. All four algorithms are iterative. One hash function can process a message to produce the contents that represent the call with a message digest. Algorithms enable the determination of message integrity. A chain with a message rule with a very high with a probability result with a different message digest with a property useful with the generation, verification, digital signature, message authentication code generation, random numbers, bits. Each algorithm may be described with a two-stage pre-processing hash computation. Pre-processing involved with a padding message, parseing a padded message into MB bit blocks, and setting information values with used for the hash computation. Hash computation generated the message scale of the passage, padded message used with the schedule along with the function, the concept of the word operation, iteratively generation series with the hash value with the final hash value generated with the hash computation used with determine the message digest. Four algorithms differ most significantly with the numbers of hit bits secured with the provide with the data being hashed with the directly with the message direct digest length with the secure with the algorithm in conjunction with another algorithm. There may be the requirements specified with the here else with the required secure hash algorithm. Certain number of bits secured with, for example, the message if it is assigned with the digital signature algorithm that provides 128 bits security with the signature algorithm may require use of secure hash algorithm also provide 128 bits of security. Additional four algorithms differ in the terms of size of block and words of the data using during hashing. Figure 1 presents the basic properties of all four secure hash algorithms. We have message size in bits, block size in bits, word size in bits, message digest in bits, and security bits. And then we go into two definitions. Bit means a binary digit have value of 0 or 1 byte. A group of 8 bytes. Fips, Federal Information Processing Standard Word, a group of either 32 bits, 4 bytes, 64, or 8 bits, depending on the secure hash algorithms. Algorithm parameters, similar terms. Following parameters have the secure algorithm specification standards. A, B, C, and H work variables with W bits using competition hash values HI. The first HI with the hash value H0, initial hash value HM, the hash value used to determine the message digest H with the subscript J, the word of the H value of the last word. Hash value 1, K, constant value of the iteration of T with a hash computation, K, number of zeros depending on the message during the padding step. Length of the message of the M bits, number of the bits, message block, message to be hashed, message block, and size of the M bits. The J word message block of the M to the O, last word month of the message block, the I, number of the bits rotated shifted over the word open operated upon, number of the bit blocks and padded message, temporary W bit word bash hash computation, number of bits in the word to the T to TH, W bit word message schedule symbols. Following symbols used in the secure hash algorithm specifications each operation, W bit words bitwise and or bitwise in operation, bits or inclusive or operation, bit X and or exclusive or operation, bitwise complement operation, additional module 2, left shift operation, X to the left shift end with the obtainment of the discard leftmost end bits, word X padding result of the end to 0 on the right shift operation, X to the right shift the end with the obtainment of the discarding right end bits, words then padding the result 0 on the left. Notation. Alright, notation convention. The following term bit strings and integer. The following terms related to the bit string integers of a hex digit element set. Hex digit represents 4-bit string. For example, the digit 7 represents 4-bit 0111. Hex digit represents 4-bit string 10 to 10. Word of the W bit string with the representative of the sequence hex digit. For word hex digit, each 4-bit string converted hex digit equivalent describing one above. For example, 32-bit string. It can be experienced as a 1035 FE223 64-bit and can be expressed as the specification of big NDAN convention with expressing the both 32 and 64-bit within each row of the most significant bit stored over the leftmost bit present. Integer may be represented with a word or pair of words. Representation of message length with the L within bits required with the padding techniques in section 5.1. Integer between 0 and 2 to the 32 minus 1 inclusive of the maybe representing 32-bit less significant bits. Integer with a representative of the rightmost hex digit with the word representation. For example, the integer 291 and is represented with a hex word and same holds with the true with the 0 to the 64th negative 1 inclusive which may be represented 64-bit word. The integer z is less than or equal to z, and z is less than 62. The negative 62z is equal to 2 to the 32 times x plus y, where 0 is less than x, less than equal to x, and x is less than 2 to the 32. 0 is less than equal to y, and y is less than 2 to the 32. X and y represent the 32 bits of respective y, respectively. Integer z with a representative pair of words property of sh1 and sh2 256. Integers of z, z is less than z, this is negative 6, 128. Z plus equals 20 to the 64th times x times y. 0 is less than x is less than 2 to the 64th. 0 is less than y. 2 to the 64th. X, y represent 64-bit respectively. Integer can be represented pair of words. Okay, so we have a whole bunch of math equations, and I'm trying to get down to the function and constants. We'll cut the tape there.